every edge exactly once and contains every vertex. Well, there's only 2 vertices. So let's start with this edge here. So I'm just going to label the edges, E1, and then I'm going to go back on E2. Then I'm going to go back on E3, and then I'm going to go over here to E4. So I started here and I ended here, and so that's an Euler circuit. So does this have an Euler circuit? So let's think about all of the ways, all of the criteria. Does it look like it's connected? Does it look like, it does look like connected, right? I can get from one vertex to another. Does it look like every vertex has even degree? Oh, it does not, does it? I think this vertex here has odd degree. So it does not, so since that is an invariant or stops us from having an Euler circuit, there is none. There's none. Okay, how about this one? Looks like all the vertices have even degree. Oh, but wait a second. Isn't this just one triangle drawn on top of another? It is not connected. So be careful, not connected. You cannot have an Euler circuit. Okay, so Hamilton was the salesman. He wanted to visit every town once, right? You can't make up a new street. And if it's going to have a subgraph, if this is going to be the graph, if it's going to have a subgraph that touches every city once, I'm going to have to be able to eliminate streets, right? That's what the edges are, eliminating streets. So let's look at this one. Is it possible for me to eliminate streets but still get to every vertex and have a circuit, which means ends and begins at the same place? So I can only have, I don't think so. If I take out this edge, right? So then I go to here, to here, to here. That doesn't work, right? So that is not possible because I can't make a circuit by eliminating an edge. Same thing over here. If I eliminate this edge and perhaps, I don't know, so when I start to eliminate edges, I can't stay connected and still have the same number of vertices and edges, right? Because this one had 1, 2, 3, 4, 5. I can't have 5 edges and make a circuit. So again, this one has 1, 2, 3, 4, 5, 6, 7, 8. Wow, that's a lot of vertices. I can't have 8 edges and keep it connected. So this is a little harder to determine, but neat. This one does not have a Hamilton circuit, and this does not have a Hamilton circuit. Okay, so let's look at this. It says connected. That's always something to look for in the beginning. Does this have an Euler circuit? So an Euler circuit has every vertex has an even degree. Will you look at that? No, it does not, right? You can't have odd degree vertices when you're making an Euler circuit. Okay, so here's just in general a graph. Has 5 vertices, okay, all even. It's looking good, right? All even vertices, or even degreed vertices. Does it have an Euler circuit? Not necessarily, because it doesn't say connected. Oh, yes, that's a big deal, Cap, to be able to be connected to make a circuit, right? A circuit. So let's look at this one. Does this have an Euler circuit? So it doesn't matter where you start. So I'm going to, just because I like ones, I'm going to start at 1. So if I do V1, and then this doesn't have edges labeled, so I'm just going to go with the vertices, right? So I'm going to go V1, and I'm just going to go down here to V4. Why not? And then, what am I going to do next? I think I'm going to go to V5. And then I'll go back to V4, right? So I went up to V5, back to V4. And then I'm going to go to V3. And then I'm going to go to V2. And then I'm going to go back down to V5. And then back to V2, here to here. And then from here to here, go back to V1. That's a circuit. every edge exactly once. So that is an Euler circuit. How about this one, part B? Does this have an Euler circuit? So let's look at the degree of these vertices. Oh, I see it. Do you? Degree 3, degree 3. So since there's odd degree vertices, there's no Euler circuit. Okay, so let's look at this one. So again, Hamilton's a little hard, right? So this looks like it has, I've even labeled them, 7 vertices. So I need to eliminate, so I only have 7 edges. So I'm just going to start taking them out, and I want a circuit, right? I want to keep it connected. So I'm thinking I'm going to get rid of that one, and there's going to be more than one answer for this, right? So what if I do this? What if I say, I'm just going to put different color. So I go V0 to V1, and then I go down to hold on a second. How am I going to get to V? Yes, I went, okay. So then I went down to here to V3, and then I went down here to V4, and then I went here to V5, and then I went to V2, and then I went to V6, and then I went to V7, and then I went to V0. There it is. So that's a Hamilton circuit. So it does work. How about this one? So how many vertices do I have? 1, 2, 3, 4, 5, 6, 7. 7 vertices, so I need 7 edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. So I need to be able to eliminate 2 edges. So I'm thinking over on this side of the graph. So if I take out, I don't know, like this one and this one, wait a minute, I'm not going to stay connected. So it is not possible. I'm not going to be able to make a circuit.